Hello. Good afternoon. First, sorry, I don't speak your language. I do understand a little. And opposite, you probably don't speak my language. So the only common is in English, so sorry for that. So that's my topic. I tried to Google translate it, and it fits to the content. That's good. So the topic is ExtremeAnalytics. The idea or the agenda for that is to explain how it works, what it is for, and then do demonstration. Okay, so let's start. ExtremeAnalytics. So first, we do have an issue in today's network. If a user calls to the help desk, they usually say, hey, network does not work. If you are, let's say, IT help desk person, then you ask, okay, what does not work? And the answer is, you know what? Facebook does not work, or the CRM does not work. Okay, good. So what I can do with that? So what I'm trying to explain, what I'm trying to mention and to explain is that people are talking about applications. People do not care what protocols are behind that, what is the TCP, UDP ports, what is behind the application. People do think about the application and the quality of user experience was already mentioned today. So if you look at how users they see applications. But the network itself, if we talk about switches, if we talk about wireless in general, they do work in line rate and talking about layer 4 maximum. So port 80, TCP, UDP, access controllers, and that kind of stuff. So if you really want to do some analytics, if you really want to make some troubleshooting, you need to translate that. And this now starts to be a little bit tricky because some applications are running on the same server, like others. You have one data center, maybe two. So at the end, you need to translate it. And now we have an issue with networking teams, like people which are responsible for applications are not the same people which are responsible for the network. So we do have something which is called ExtremeAnalytics. And the ExtremeAnalytics is able to give you at the line rate and 10 gigabit speed and 40 gigabit speed in terabit speed in total. Okay? It can give you the full layer 7 visibility to whatever traffic you pass through the network with no performance degradation, every single flow, every single packet. Okay? So imagine what you can use and how you can use your information which you can get from the network if you have the visibility to applications, layer 7 visibility. So in general, there are three, let's say, use cases or group of use cases. So use case number 1 is business analytics. So if you think about what is happening, what is transferring over the network in enterprise today, if you think about that, you will see that the company is not able to issue an invoice without the network. The company is not able to send any goods out without the network. So everything is going through network. So if you understand how your network behaves, what is transferred, how your users are using the network, you can turn the IT department to be a business friend for the decision makers. Okay? So experience which we got as a feedback, as a use cases from our customers where we deploy the solution. Okay? So first, business analytics. I mentioned there are other two, which I will go a little bit later. So regarding business analytics, use case number 1. So real-time monitoring of business application licenses usage. So there is a company which is called Panasonic. Have you heard that, right? So Panasonic is a global brand. So in their factory, we deployed that solution in the proof of concept and testing. And immediately it returned to the business benefit because the company, the customer, find out that they are paying 250 licenses, concurrent licenses for SAP. But the maximum which they use is 100. Okay? So they were able to monitor the usage of the application from the concurrent session point of view, because we can. Okay? So that was use case number one, which immediately turned to the return of investment. The use case number two, sorry, no one used a specific virtual machine for more than 3 months. So why the virtual machine is used, why the virtual machine is running, why the virtual machine is consuming the CPU, consuming the memory, maybe also licenses. Just think about that if we see the traffic, in the data center, we can tell, hey, this virtual machine or this particular entity did not transfer any data for some period of time. Or opposite, we can tell which users are using that application, when they are using that application. Okay? So this is something which is a general term in the industry called VM sprawl. The issue is that today, to create a new virtual machine, it's so easy, like 3-4 clicks, and you have a new SharePoint server. No trouble at all. Okay? With virtualization, just choose template, apply, and you are done. The trouble is that people which can't do that can easily use it, so they are running it and creating virtual machines for testing purposes. But we are only humans. So what they do, they create it, they test, and they say, okay, yeah, you know what, tomorrow I will use it again. But tomorrow will never happen, because tomorrow they are using something else. So at the end, they have hundreds of virtual machines, which no one does remember why they were created, why they are for, and what is it used for. Okay? So use case number one. So no one used the virtual machine for a period of time. This one is also from the customer. That was a really nice example. I asked the customer, okay, what are your mail servers to create some templates in the firewall later on? And I got a list of 3. Then I used that and see, what about this one? This one does not work anymore. The IT director said that this one does not work anymore. It was decommissioned. I said, okay, so I can tell you what users are sending email through this decommissioned server. The server was returned to the service by mistake. Okay? So it was something which can happen, and I met it already twice, that people are troubleshooting what is happening, and they found this turned off server. So, oh, that's the issue, because the server should be up. So they started. Okay? So that was another use case. So the email server, which was not expected to be working, was in the network. This one was something like this, on a customer event like this one. We had 50 people in the room, and there was one person who transferred over 1.6 gigabytes of data through the day, through that event. Okay, there was a lady who just uploaded all the streaming to some storage. Okay, why not? But if you have this information, that's good to know that something such is happening. So, some use cases from the second option, which is the security analytics. So if you have the visibility to full traffic on the perimeter of your network, on access of your network, on the data center, on the core of the network, you can use the visibility also for security purposes. So some use cases from this, let's say, group. I like this one. So if you look at the printer, sometimes you are really surprised. So for example, I was surprised that on that printer there was a Windows running. And people were using that Windows as a file share. So instead of using corporate file share, which was protected by the DLP and all those stuff, they were sharing the data through the printer. Yeah, is that compliant? Probably not. Is that good practice? Probably not. Can you discover that? Not easily, correct? So if you see the traffic, you see applications, and you see that printers can be sending emails, for example, or using as a storage. Layer 7 visibility as a part of the network behavior anomaly detection. So if you have security information event management, like QRadar, like whatever, just this is an example, So you can store all your information about each and every communication which is happening in the network for some later analysis from the network behavior anomaly detection point of view, or just for the statistics point of view. You can see each and every flow, each and every traffic. This one is something which I like. The user has found that the UDP port 53 was opened. So the user used this communication channel, DNS, for the VPN. So he VPN'd out and sent some traffic out of the network. Not usual thing to tunnel the traffic over the UDP, over the port 53. Could be done, could be detected very easily if you see everything. The biggest, let's say, topic or use case group is the network troubleshooting. So if you see each and every flow, and we do something even more, we do measure the quality of service. So we do measure something which is called network response time and application response time. Okay? So if we have this information, we can use that knowledge for the network troubleshooting. So, for example, we found out that local ISP where the customer was connected did something really strange and wrong. That ISP had wrong routing table and was sending everything for a specific subnet somewhere in the US, was sending it to the customer router. Okay? So first, the customer paid for the connectivity. But the ISP was using that just because of mistake. Okay? The second thing was that someone from that ISP was not able to reach that subnet because it was sent to the customer, and the customer, of course, drop it, right? So that was something really weird and strange, which can happen. This one is from the hospital. So there was a customer, there is a customer, which complained about the Wi-Fi. You know, the Wi-Fi 5 years ago and Wi-Fi today is completely different. There was a session regarding that, regarding the evolution of Wi-Fi. So the customer thought that the Wi-Fi is old and was thinking to replace the Wi-Fi network because users were complaining that the Wi-Fi does not work well. The reality was that the Wi-Fi was working fine, but the utilization of the Wi-Fi was different. And even more, the application was designed wrong. The application has used really small sessions, which were not able to aggregate, so they were not able to utilize the 11N or 11AC standard to have better throughput. Okay? So a lot of transactions, which was here the issue. Okay. The customer configured this solution to verify if all VPNs to all his customers were working fine and all the time. It's not just because or if the VPN tunnel is up, but also if the traffic is going through the tunnel. Okay? So that's another use case for network troubleshooting. If you see that, you can easily work with that. Okay? Network and application response time are key for troubleshooting, so that will be the demonstration. So if you see the network response time and application response time, there is a really nice feature which you can get from, or benefit which you can get from the solution. So today, there is a new term which is widely used in the industry, and that is called mean time to innocence. Okay? So imagine that someone come to you and say, hey, the network sucks. And you are the network admin. What do you need to do? You need to find the proof that my network does not suck. My network is good. Okay? But that guy will get the innocent report from you and will say, okay, application sucks. And the application user, the application person must do the same thing. And I say, okay, so if the network does not suck, if the application, client sucks. Okay? And then what? then the client needs to, hey, my client works fine. The issue is not on my side. Can you imagine that you have a tool which will save your time to creating the report? Like, hey, look at that. It is not my issue. The network response time is 10 milliseconds for that particular user, for that particular application. But look at the application response time. Blame them. It's not me. Okay? But you have a report. You have a real data which are measured. And the important thing is that these data are measured independently. So I'm not asking the application, hey, Mr. Application, are you going fine or not? And if the application has time, oh yeah, I'm going good. That does not happen. I see the traffic, I see it on the network, and I am independent. I can do that. The next one. Oh yeah, periodic long response times, as a storage showed issues with backup of patient system. Yep, so if you design the network and you are running on the same network the backups, of course, at the backup time, it can be stress for the network. How much, and is it really the issue or not, you can detect that. So if someone calls to the help desk and say, hey, you know what? Yesterday evening, that was terrible, but today it works fine. You can go and say, hey, what was happening in the network yesterday evening? And you can say, oh yeah, I see that. Backup was going over the link. Okay? So, network troubleshooting. This one is from a huge hospital in Berlin. So, they do have two data centers. They do have a data center interconnect between two data centers. And what happened is that, of course, user called, yeah, the network is wrong, the network sucks. But what they did create a ticket, okay? The network sucks. Well, the network is fine. Application sucks. Application is fine. Database sucks. Application, the database, everything is fine. And then they have a look at the behavior of the network, and they found out that in their two data centers and interconnect link, they create a wrong group of servers. So they forgot to include one server to the group. So when the group of servers migrated to the backup data center, one remained in the primary data center. And then the data center interconnect was used so heavily with so response and latency that it created an issue for the customer. Okay? So the network was fine, application was fine, database was fine, the client was fine, but the user experience was bad. Okay? Because of this stupid small mistake. Okay? I have more. This one, okay? The server, oh yeah, the issue was, okay, all my internet connectivity is consumed. So what they did, they applied just a standard analytics, like the net flow analytics, and they found out, and that's something which you can get from the logs somehow, they found out that this is a server which is consuming 98% of the link. But the server was important. They could not reboot the server. So what they did, they tried to analyze more. And they found out that it is port 443. Excellent. Encrypted traffic. And it was not one IP address. It was not a specific communication. It was a lot of servers which were talking. The server was talking to those, to those destinations. So they rebooted the server. Emergency situation. They rebooted the server. And in 3 days, it happened again. So then they applied our solution from the analytics, and we found out that it is not a port 443. It is port 123. It is port 443. But that was the CRL, the certification authority, was trying to download CRL periodically all the time. Okay? So they found out what is the application which is causing that, and they were able to fix that server with the patch or reconfigure it to use it correctly. Okay? So, CRL. Yeah, this happens, you know, I'm doing a demonstration, the real demonstration, so with PowerPoint it works fine every time, but it's good to make the impression and good to demonstrate it. So we had a session like this, we had it in Ljubljana, in Slovenia, and it was funny because the network was very bad. The user experience was very bad. But if you look at all applications, we're fine except DNS. So there are several protocols which can ruin the user experience. DNS is one of them. Kerberos is one of them also. If user is not able to log in, authenticate, the DHCP is one of them. Radius protocol, which is used for authentication, is also one of them. Okay, so we have DNS response time something like 2 seconds plus. Okay, so each DNS was terrible, and that had really big consequences. So, how it works? What is the magic behind that? Okay, so the solution itself consists of 3 components. The component number 1 is something on the screen on the left, which can be a sensor. The sensor is good because the sensor can go to any network. I know that, all customers are not perfect. Some of them are not using our equipment. So if the customer is not using our equipment, okay, the sensor can be used. Another option is a switch. Okay? The switch can help. The switch can help you to work as a sensor. So the traffic going through the box can do the job. The third option is an access point, extreme wireless access point. Okay? So the access point, switch, or a sensor can be a source of information. So why and how it works? So the device here does have something which we call custom Asic. So there is a CPU, there is a processor which is handling the traffic. And if you think about that, it is the custom-based Asic which works on a really specific approach which is called flow-based Asic. What that means, if the frame comes in, it can be mirrored to the sensor or it can go through, then the Asic chip will create a flow table. So it will take the source MAC address, destination MAC address, source IP, destination IP, TCP, UDP ports, and will create a table on that. So for each and every flow, there is a table, there is a row in the table. Okay? And the row does have counters, like amount of packets and amount of bytes. So the device itself is able to generate something which is in general called net flow in hardware. What I mean by this, it's a scaling. Okay? So the flow table has 1 million of records per 10 gig port. Okay? So this sensor which is on the screen does have 4 10 gig ports. But we do have switches or sensors with 32 10 gigs. Okay? We do have with 64 40 gigs if you really want to make a data center fully visible. Okay? And each port does have a huge amount in the flow table. Just comparing that to, let's say, standard silicons, which can do NetFlow or S-Flow, where we are talking about 1,000 or 2,000 flows per switch. Okay? So this is the scaling thing. The second thing which this switch or access point or sensor is doing, it is able to create something which is called first-N mirror. What that means is that from each and every flow, we mirror the first 15 frames. It can be 30, but in general, it's 15 frames. So for each and every flow. So if I start to download 1 terabyte file, I will see first 15 frames from the download. Okay? So going here, analytics engine. So this guy takes the net flow data, which tells how much of the traffic was transferred, when the traffic started, when the traffic finished, what interfaces it was seen on. Okay? And it takes the first-N mirror, and from the first-N mirror it will see and run the DPI, it will see the application itself. Okay? So if it is SSH, it will see, hey, I'm SSH server, hey, I'm SSH client, let's talk encrypted, and I do have information, it is SSH. I don't care if it is on port 22 or 4000. I don't care. I see the content. And from the net flow, I see when it started and when it ended, and the statistics. So I can combine that together. Okay? The third is extreme management. Extreme management is the network management and extreme control, which is my next session, talking about extreme control, about the network access control and visibility to the end systems. Okay? So then we can combine those information together, and we can create beautiful reports for your bosses, for your management, but we can make queries. We can send the information out for storage. So you can work with that. So we combine all those things like the network information, like what is the port name, like what is the switch location, what is the port where the user is connected, what is the SSID where the user is connected, what is the username, what is the host name. We combine that information with the analytics. Okay? So then you have full picture. I was talking about measuring the response time. So this is how it works. So on the left side, I have a client. On the right side, I have a server. And in the between, I have something which is called sensor. So if there is a TCP session, then there is a TCP three-way handshake, right? Send, send, acknowledge, acknowledge. So if I take the timestamp of SYN and timestamp of SYNAC, I have something which we call network response time. So what I do believe that the drivers and operating system is something which I can ignore. Okay? There is nothing which the application can influence. That's a pure network thing. Then if I see request and I see the response, again, I have timestamps. Oops. I have timestamps, and this is something which is called application response time. So then the application is involved in the delay. So for each and every TCP session, we do have network response time. And for applications which are running over TCP, or applications which we do understand what is the request and what the response is to that request, we do see application response time from the traffic which is on the network. Demonstration. Okay. Thank you. Any one of you have seen this? Really? It's Extreme Management version 8, which will be available in June this year. Okay? So this is the future. The reality is that I can show that also, and that's already on the booth there with version 7.1, which is available now. But I would like to show you something really new. Okay? So the solution is available already, no trouble at all. And this is the version 8, how it looks like. So there is not really many changes, so it is still web-based. The menu is on the left now. So if I go to application flows, just to refresh that, you can see, oh yeah, what I have here. I'm connected by the wire to a beautiful demo kit, which is just behind the wall here. So you can see that I do have some information about the flow. Like I do have, you see that I'm using my iPhone. This is the server IP address. This is the web port, application, like demo, like AirPlay, like eBit, Google, VNC, whatever. I see the application information, like metadata, like the URL which I was asking for, or who issued the certificate. You see that this certificate was issued by Enterasys. Good. Still having certificates from that time. Okay, and you see the network response time, and you see application response time for each communication. You can see that this guy was 40 flows, and I can go to each of them quite easily, but this is 40 flows for the same thing. Okay, you see the location, and if I scroll to the right, you see the SSID, you see the radio, You see the access point name and you see the wireless controller IP address. You see the server location and you see who did that. So you see that I do have some users here, like user with the name stuff, like user with my name, okay? Oh, look at that, Marilyn Monroe. Well, we do have that lady here. Good, running on my tablet. Okay, so we do have a profile. So what is the authorization that end system got? Okay. And then I do have all those details. Like amount of packets, amount of bytes, when it was last seen. Yeah, of course, the time zone, I'm still in the Central European time zone. So yeah, plus 2 hours is the real time here. I see the interface, the flow source, who reported that, if it was wireless controller, or I saw that by the sensor, and that kind of stuff. So of course, I can search for anything I would like to. Like I have here some search criteria. The cool thing is this. I can go to browser. So I can browse. So, Mr. Analytics, show me in the table applications for last 3 days. Why? Because today I don't have internet here. This bloody wireless Cisco does not accept my client to connect. Okay? So I do have only generated traffic. Yesterday I was traveling, so the day before yesterday I had real traffic. Okay? So show me the last 3 days and show me amount of traffic which was transferred. Location, okay, just my network, top 30 applications, done. Okay? So the application number 1 is eBits. I will show you eBits a little bit later. So that's an application to showing network performance. Okay, just transferring a huge amount of data. You can see that I transferred over 15 gigabytes of data, 70 up, 70 down, 7, not 70. Okay, then I have some beautiful applications like Box, like encrypted web, like VNC, Avaya, Google, whatever. I was just browsing and doing my daily business. Okay, so talking about response time. Let's go to, not showing bytes, okay, good, but show me amount of flows in my lab. DNS, how heavily it is used, okay? DHCP, these are the really important applications. If you think about the designing of firewalls, this is exactly the information you need, the amount of flows. If I go and say, okay, show me the worst application response time, Avaya and Extreme. Yeah, but look at that. Look at that. Avaya response time, 429 milliseconds application. And the network, 83 milliseconds. I'm a network engineer. Hey, blame them, right? What about the Extreme networks? 328 comparing to 111. Ah, yeah, the network is worse. Okay, iCloud, yeah, Apple works. 112 comparing to 110. Wow. Okay, so just choose the metric you would like and just browse. So for example, show me Marilyn Monroe, right? So show me applications which user Monroe transferred. Extreme networks. Worst application, 717. Okay, iCloud was good. Okay, so show me applications, that's what I see. Okay, show me clients for, again, demo kit. I don't care about profile. I don't care about application group, that's fine. I don't care about device family, but show me clients using application Extreme networks. Okay, Marilyn Monroe does have it bad, 717. But me itself, 133 milliseconds. So it's not true that the application sucks for everyone, right? Because for me, it works. So look at that. Maybe it is connected with the device family, with the device browser. And that was a use case which we found something like 2 years ago. We found out that the ExtremeNetworks website sucked for Android. For Apple worked fine, for Windows worked fine, but for Android it was not working fine. Okay? You can see location, you can see profile, application device family. Okay? So you can point that and look at whatever angle you would like to. Okay? Another thing, look me, not a table, but show me chart over time. And the same. Okay? Look at that. So 125, 142, and this 700. So it's not true that the application sucks for everyone every time. Okay? So show me that for the username Monroe. Oh, okay. Maybe it is, because it was me, of course. She accessed the page only once. Do you see what you can get? Okay? Terabit speed in your data center. You don't have to have ExtremeNetworks equipment fully. It can be just our devices as a sensors. It can be our wireless. Okay? And of course, we do have reports and dashboards. So you can see that I did some generated traffic, like Facebook. I do have something like almost 2,735 clients. This is the amount of traffic, and you can see all the beauty here. Yeah, this was the time when I did the performance tests. So different points of view. We do have IP reputation, not in my lab. So you can feed the reputation and you can see that what traffic is going to compromised servers. You can have dashboard, which is automatically generated, real time. So you can see the network response time, you can see the application response time. You can see that for a specific application which you just filter. You can create group of applications, that's it. So if we talk about these critical applications like DNS, DHCP, Kerberos, Radius, and LDAP, here are my dashboard, okay? That's a lab, okay? I don't have any real Radius server there. I don't have any LDAP. I don't have any Active Directory, so that's the reason why it is empty. But I do have DHCP. I do have DNS. And the most cool thing is the amount of applications we do support out of the box is 7,000. The amount of fingerprints for those applications which we do support out of the box is over 13,000. So the fingerprint is the definition of the application, okay? How we recognize the application. So look at, for example, I was a child one period of time, and I played games. At that time, I played Diablo 1 and Diablo 2. But there is a Diablo 3 which is online. So look at that fingerprint. This is the definition of the fingerprint, where you can see, okay, it is HTTP field URI, pattern, field user agent, Battle.net, Blizzard, web client as a Perl-compatible regular expression. So I'm not playing the game with IP addresses or with TCP ports. I'm looking at the content. So it can be the name of the certificate for HTTPS traffic. It can be anything in the HTTP header, or it can be anything in the flow, in the content. Okay? with the DPI engine. Okay? So you can create your own applications. So of course, you will use your applications which are not on my list. We have the greatest list ever, 7,000 applications, but that's unfortunately not all applications in the world. So you can create your own. You can do that, or partner can do that. Спасибо. Oh, I said I don't talk. Yeah, I do have some words. Thanks. So you can create your own. You can create your own applications, fingerprints. Okay. You, partner, or we.